So good afternoon everyone and welcome to our next discussion. For today, we will be continuing with the operations on the algebraic expressions. And this will be the last part, which is all about the division of algebraic expression or division of polynomial algebraic expressions. And for you to be guided easily, I'll be breaking this discussion into three parts. The basic, part one, which is all about the division of algebraic using the law of exponent and the cancellation. And the second part will be the division of algebraic expression by factoring method. And the last part of this operation will be the division of polynomial algebraic expression using the long method of division. Okay, so let's get started. Okay, so for the part one, let us divide algebraic expression using the idea of the law of exponent, one of the laws of exponent, and together with the cancellation method. Okay, so for this part, okay, so let me call this one as division by quotient of powers. Okay, so that means we will divide algebraic expression using the idea of the quotient of powers. Okay, before that, let's talk about power. Okay, so for example, you have this expression a raised to the power of 2, for example. Let us be familiarized once again the parts of the exponential expression. Okay, so for this one, a raised to the power of 2 or a squared, a, we call this one as base. And this one, the small number written at the upper right hand, we call this as exponent. The whole expression is called power. Okay, so now you have your idea again, once again, what do you mean by power? That is why sometimes we read this one as a raised to the power of 2 or a squared. Okay, so that means when we talk about quotient of powers, how are we going to use this one in terms of division? The quotient of powers, that means there is numerator and denominator involved because of the term quotient, or there is dividend and divisor. And we are using powers because there are more than one powers being used here. Okay, example, we have a raised to the power of 2 over raised to the power of 2. For example, okay, so this is the first case under this one. You have, for number one, you have a squared over a squared. So why is it quotient? Because it is in the form of division or fraction, where this one is the dividend and the second is the denominator is what we call the divisor. And power, because the numerator is power, there is base and exponent, and the denominator, which is the divisor, also has power, the base and then the exponent. That is why this expression, we call this as quotient of powers. And at the same time, the quotient of powers, the idea here only involves where the base of the numerator and the base of the denominator are the same. So as you can see, the numerator has a base as a as the base, and the denominator has also a as the base. So again, for the quotient of powers, we are talking about the bases, or the base of the numerator and denominator are the same. Okay, so what are we going to do here? So for this one, according to, if we apply the log exponent as part of the log exponent, the quotient of power, a squared, or shall I say a squared over a squared, or just this one. Um, anyway, I have to give this one directly. If the bases are the same and the exponent are the same, it is just equal to 1 directly. Anyway, this is just a review. So, if you are dividing expressions where the bases and the exponents are the same, then it is just equal to 1. Just cancel directly. That is why, while ago I said we are going to divide these algebraic expressions using quotient of powers and cancellation method. So this is the case now. We're using the idea of quotient of powers and at the same time the cancellation. So again, if you have the division expressions where the bases and the exponents are the same, just cancel both numerator and denominator and give it as 1 for the answer. Okay, so for number 2, you will have, again, under this one, you will have 3 raised to the power of 2 over 3 raised to the power of 2, or 3 squared over 3 squared. So again, if this one, okay, if the bases are the same and the exponent are the same, just cancel them directly, and that is equal to 1. Okay, another one, for example, you have 4x cubed over, for example, you have x cubed. And this quotient of powers for cancellation method is very ideal when you divide monomial by monomial expressions. Meaning, you are dividing algebraic expressions having one term only. So what you are going to do? So for the numerator, you have 4x cubed, and denominator, you have x cubed. So since for the variables and the same are, and the exponents are also the same, so you just cancel them directly. And the result is 1. So if you are going to show this in detail, so just bring down or copy 4 and then times 1. Where did we get 1? This is the result when we divide x cubed divided by x cubed, where the final answer is 4. Or you can directly give 4 as the quotient of this 1. Okay, so another one we may have, for number 4, we may have 2x raised to the power of 4 over 3x raised to the power of 4. So the idea here, again, what is being presented here is when we divide expressions where bases are the same and the exponents are the same, to apply this first equation about quotient of powers. So since x raised to the power of 4 is also the same in the denominator, so we just cancel. So what remains here, just bring down 2 over 3 times 1, or just simply directly, your answer is 2 over 3. Do not cancel along the 2 over 3 because these numbers are not the same. So the final answer for number 4, you have 2 over 3. That's how you simply divide the algebraic expressions using the quotient of powers, where the situation is the numerator and denominator have the same basis as well as their exponent. Okay, so after the quotient of powers where bases and exponents are the same, there is another one also. You have the next one is when you divide bases where bases are the same but the exponents are not the same in this case also. Again, I am not going to present the quotient of powers so detailed because this is just a review of the one of the laws of exponents, that is quotient of powers. I am directly applying here the idea. So for this one, this is the scenario here. If you are dividing under the quotient of powers, if you are dividing the same basis but exponents are not the same, um, what you're going to do is retain the variable that has the bigger exponent. So in this case, this one here, the numerator has bigger exponent compared to the denominator. So that means just bring down the numerator and copy the exponent. And then by bringing it down, after that, you subtract, okay, the exponent of the denominator from the exponent of the numerator, that is 3 minus 2. By doing this one, by subtracting the exponent of the denominator from the exponent of the numerator, and what happens here is you are removing the variable here. So what remains is the variable of the numerator. So that becomes x raised to the power of 3 minus 2. The answer is x raised to the power of 1, or just simply, when the exponent is positive 1, just remove it, and because it is always there even if it is not written. So therefore, x cubed over or divided by x squared, by doing the process using the idea of quotient of powers, the answer is x. However, for the cancellation method, you can do this one. Supposedly rewrite x cubed over x squared. Can you still remember when we multiply, what will happen when we multiply the same variables? Okay, so you can apply the idea as a reverse form. So that means x cubed is derived from x times x and times x. And also, x squared is a product of x times x, because when we multiply the same basis, the idea is copy the common base or the common basis, just copy it as a single base and then add their exponent. So this time, we are applying the reverse. And then after that, cancel the common numerator and denominator, and the one, the remaining here is only one x, or the single x, so x raised to the power of 1 or just simply x. So you can also do this way. But in terms of higher algebraic expression, when you divide, just do this one mentally. Do not show this as part of your solutions, because you are not, unless you are grade 7. Because for the grade 7, this is the step-by-step basic presentation on how to divide using quotient of powers and cancellation method. So either you will use this idea or this one, so just do it mentally if you are in higher mathematics. And again, this is just a review for you. Okay, so another one. If you have here, for example, you have 5x raised to the power of 4, and then over 7 raised to the power of x squared, 1. So what you are going to do is just copy these numbers, this fraction, the 5 over 7, because you cannot divide 5 and 7, or not even reducible into lowest term. So you just copy 5 over 7, and then then work for this one using the quotient of powers or cancellation if you want. And then since the numerator has bigger exponent here, the variable here has bigger exponent, so just bring down or copy the variable in the numerator and copy also the exponent and subtract the exponent of the denominator from the exponent of numerator, that is 4 minus 2. And when you do this one, automatically you are eliminating the variable in the denominator. You can extend this line now. And then just copy 5 and then x raised to the power of 4 minus 2, that is equal to 2 over 7. So this is your answer under this one. So just remember how to apply this second scenario when you are dividing the same basis but the exponent of the numerator is bigger compared to the exponent in the denominator. Or if you are going to use the cancellation method, so you have here for 5x raised to the power of 4 over 7x raised to the power of 2, and you might break the variable into 5, or you can do this one, x raised to the power of 2 times x raised to the power of 2. Unlike here in number 1 that we are expanding the expression here where the exponent is equal to positive 1 all. And while this one, you can also do this process by simply breaking the variable that has bigger exponent where one of the variables is equal, where one of the variables here, just like this one, where one of the variables has the same exponent as in the denominator. So means you can just, in this case, you can just bring down 7x squared, and after that, since this one, x squared and x squared, this, okay, variables here, this new x squared in numerator and x squared in denominators, okay, are having the same variables and exponent by using this first scenario, so just equal to 1. Okay, so you don't need to copy 1 anymore if there are other terms or numbers being still in the answer. So just copy 5x squared, 5x squared, and then over 7. So this is now your answer for that one. Okay, the last scenario under quotient of powers will be the last scenarios under the quotient of powers will be when you are dividing the same variables, but the exponent in the denominator is bigger than the exponent of the numerator. In this case, for example, x cubed divided by x raised to the power of 5. So this is the third scenario under quotient of powers. The first one, when we divide, to recall, the first one when we divide the same variables with the same exponents. While the second scenario here, okay, possibility is that when we divide the same variables but the numerator has bigger exponent compared to the denominator. And the third scenario here, the last, where you can divide algebraic expression directly and easily, under this third scenario is when you divide the same variables, but the exponent in denominator is now bigger compared to the exponent in numerator. Again, the exponent of denominator is bigger compared to the exponent of the numerator. So what will happen here, in this case, the one with the bigger exponent, just copy this one. Since the denominator has bigger exponent, you just copy the exponent in the denominator, also the variable and the exponent. So x raised to the power of 5. And then subtract the exponent here from the exponent of the denominator. That becomes 5 minus 3. By doing this process here, the variable x in numerator is being eliminated, and what remains for the numerator is only 1. And if you continue, that becomes 1 over x raised to the power of 2. 5 minus 3 equals 2. So that means x squared over, or x squared divided by x raised to the power of 5, it is equal to 1 over x raised to the power of 5 minus 3, or just simply 1 over x squared. So that's it. That's how you apply this idea, or this scenario number 3. And if you try also to apply the cancellation method for number 1, for this scenario, the cancellation here is, okay, so you have here number 1 the same, that is x cubed over x raised to the power of 5. Just simply rewrite x cubed to save spaces and factor out the variable and the exponent, where one of the factors has the same exponent as the numerator. So for x raised to the power of 5, you can factor that one into x raised to the power of 3 times x raised to the power of 2. And just to recall, when we multiply algebraic expression, if we multiply the same letters, what will happen is just copy the common variable and then add their exponents. So x cubed times x squared, that becomes x raised to the power of 5. So after factoring this out, you can now cancel x cubed and x cubed here. So what remains is, since there is no more in the numerator, you replace the result is the remaining value for numerator is just simply equal to 1, and for the denominator you have x squared. So that's it. The answer is 1 over x squared. Example, you have another one. Let's try to use a number. For example, you have 2 raised to the power of 3 over 2 raised to the power of 5. So bases here, the two bases here for numerator and denominator are the same number as number 2. And then you can still do the process by divide these numbers using the idea of quotient of powers. And since the bases are the same, so you may continue just use 1 for the numerator and then copy 2 for the denominator, as well as their exponent, the exponent of the denominator, and subtract 3 from the exponent of denominator. Subtract the exponent of the numerator from the exponent of denominator, so that becomes 5 minus 3. And if you continue, this will become 1 raised to the power of 2 raised to the power, 1 over 2 raised to the power of 2, because 5 minus 3 is equal to 2. And since this is number, you have, or you need to simplify 2 squared, and that is equal to 1 over 4 here. Or if you use the cancellation method, that becomes 2 raised to the power of 3 over 2 raised to the power of 5. You can factor out the power that has bigger exponent, and that becomes, just copy 2 cube, break down 2 cube, and then you may factor 2 raised to the power of 5 into 2 cube times 2 raised to the power of 2. And then after that, try to cancel out here, and then for number 1, and the remaining value is 1, since you have cancelled already the 2 cube, and then copy the 2 squared for the denominator, and that is equal to 1 over 4. Do not forget that if we are using actual values or integers or numbers, you need to simplify at the end if it has exponents. Unlike the variable, that you just retain this one as the answer, since you cannot simplify x squared into a number. Okay, so how about if we have this one? The last one we have x cubed. For example, you have 4x cubed over, okay, 2x raised to the power of 7. So what is the result? So you can also do it's either you will use this one or this cancellation. By cancelling, that means you are expanding sometimes. Okay, you can do this one. First, you will begin with 4 divided by 2 times. For this one, since you have now the x cubed over x raised to the power of 7, so just simply copy the variables, the x raised to the power of 7, and then use 3 to subtract from 7, that is minus 3. And then for this variable part, so what remains here is 1. And then that becomes, for 4 divided by 2, that is equal to 2, since 4 is in numerator, so your answer must be in numerator also. And then you copy that one. Times 1 over x raised to the power of 7 minus 3, that is x raised to the power of 4. Or your final answer is 2 raised to the power of 2 over x raised to the power of 4. Again, your answer is 2 over x raised to the power of 4 here. So, if you want to answer this one by using this idea, if you want to find out what is the quotient here, using this idea, you can still do that. You are free to choose which method you want to use. It depends on what is convenient for you. So I guess I have just presented in detail on how to divide algebraic expression using the idea of quotient of powers and the cancellation method. I hope this will be enough for you to recall and to remember this part of the laws of exponent that can be used to divide algebraic expressions. And if you have any questions, you may give your comments if this will be uploaded. And for this time, we will take a short break. When we come back, we will proceed to the next type of division of algebraic expressions, that is by using factoring method. Okay, thank you, and